Alright students, so we are talking about arithmetic sequences. Specifically, now an arithmetic sequence is a sequence that has a common difference between terms. So if we look at the sequence 4, 7, 10, 13, and so on, we can see there's plus 3, plus 3, plus 3 in each one of those situations. So arithmetic sequence, common difference, same thing added or subtracted from each term to the next. So let's go ahead and make a table here. I'll have the n term, like the n identifier here, going down in that column. So term 1, term 2, term 3, term 4, and then what the actual value of that term is. So 4, 7, 10, 13. What we want to do is we want to kind of explore this and see if we can come up with a nice equation that'll work not just for this arithmetic sequence, but for any arithmetic sequence. So just sort of exploring this, we can see that the first term, 4, we could think of that as 4 plus 3 times 0. The next term we could think of as 4 plus 3 just times 1, I guess, if you want to think about that one. And then the next one, 4 plus 3 times 2. So 3 plus 2 is 6. So 4 plus 6 is 10. And this next one, 13, we can think of that as 4 plus 3 times 3. So we notice here that there is a relationship between this multiplier here and the n, namely it is 1 less than that. So I would say this is like 4 times 3 times 1 minus 1. Here it's 4, oh, that should be a plus, sorry about that, 4 plus 3 times 2 minus 1. 4 plus 3 times 3 minus 1. Because you see the 2 minus 1 is the 1, the 3 minus 1 would be the 2. Once again, now I did make a mistake. In between this 4 and each one of these 3's, there should be a plus, but I think I just got carried away there. So, what else is going wrong here? This should be 4 minus 1 right there. So here we have 1, 2, 3, 4, which corresponds to the n. So the explicit formula would be that the nth term is equal to, notice we had 4, that first term, plus the common difference, so that's d, we can see there's a 3 in all of those, times n minus 1. So we can see they all had that a1. This term right here was always the n minus 1, except for this one right here where I should have made that into a 4. Alright, so that's known as the explicit formula for a sequence. We can also talk about the recursive formula, where the first term is normally given to you, a sub 1 equals a sub 1, and the nth term is equal to the n minus 1 term plus d. It's a type of situation where if you're looking for the 10th term, well, that's equal to the 9th term plus the common difference. If you're looking for the 9th term, well, that's equal to the 8th term plus the common difference. Okay, and we can build it. We'll look at that here real quickly, an example of how to use that recursive formula, how to build up a sequence from it. So a1 is a1, so in this case it's just 4. a2, or an is equal to an minus 1 plus 3. That's our recursive formula for this particular example. So so building a1 is a1. a2 would be, applying the formula here, would be a of 2 minus 1 plus 3. So 2 minus 1 is equal to 1, so this is equal to the a sub 1 plus 3. So the first term was 4, so 4 plus 3 is 7. So all of that to get to the final idea that the second term is 7. For the third term, that's equal to a sub 3 minus 1, so you just plug in the 3, plus 3. So that's a sub 2 plus 3. So a sub 2, as we can see up here, was 7. 7 plus 3 is equal to 10. And the fourth term here is the third term plus 3. So that's going to be 10 plus 3, which is 13. The fifth term would be the fourth term plus 3. So that's going to be 16. So you can kind of see going down the line here that the fifth term is the fourth term plus 3. The fourth term was the third term plus 3. The third term was the second term plus 3, and so on and so forth. So we get this recurring idea. It's recursive, like it's like recalling the formula itself over and over and over until you get all the way to the bottom of the list here, or the top in this case, I guess. And this is what's called a base case. If you study programming or computer science, normally in the second year course you talk about recursion. And that's what we're looking at right here. So that's kind of cool. All right. So let's go ahead and look at one more formula. This sequence I like a lot, apparently. So 4, 7, 10. So this is A1, A2, A3, A4, A5, A6, A7. Just sort of going through and labeling all of those. So we have the advantage here that we can see a pretty big chunk of this sequence all in one shot. But we'll just pretend for a moment that most of this is hidden to our knowledge, except maybe that we're told that A sub 2 is equal to 7, and we were also told that A sub 6 was equal to 19. From that, I can write terribly. I can reason that there are from A2 to A6 1, 2, 3, 4 hops. Okay, so 6 minus 2 is 4. So there were 4 hops, 4 terms between those. Or, well, 4, like I said, hops is the best term in terms of talking about how many there are. The absolute distance there from 7 to 19, the total distance, so that's 19 minus 7, so 12 is moved a distance of 12. So we moved a distance of 12 units over the course of 4 hops. So that means we did 3 units, so to speak, per hop. That's the common difference. So one way that we can think about this just generically, we can say that maybe our final position is equal to our starting position. So like for instance this 19, that A sub 6 is equal to the starting position over here, plus the number of hops that we made, times the hop distance. So how it is the distance of 1 hop. So yeah, that seems to make sense. So the way that we could write that with a formula is that the nth term is equal to the mth term, so A sub m, plus number of hops. We found that over here just by doing 6 minus 2. We could do that in this way by saying A sub n, or n minus m, that final term minus the initial term, the index that is, times the hop distance, which is d. This is a formula which will serve us well, and we'll use it here in a couple minutes. Alright, so let's go look at some problems. So it's going to start off real basic here. This says the first three terms of an arithmetic sequence are as follows: 8, 2, and negative 4. So we can see that we're subtracting 6 each time. So just to carry that process on, 4 minus 6 is going to give us negative 10. Negative 10 minus 6 is going to give us negative 16. And we're done. That's all we need. Great. We slow down, or go down here for a little bit. This says, suppose that a sequence is defined as follows, and we have A1 equals negative 1, A sub n equals negative 3 times A sub n minus 1 plus 6. This is a recursive formula. That's great. So this is basically saying negative 3 times the previous term plus 6. And we're going to list these first 4. So negative 1, that's already taken care of. A sub 2, so I'm going to write this all the way out in the formula. We don't necessarily need to do this every time, but at least 1 or 2 times till we get the hang of it. So it's negative 3 times, and I'm just plugging in the formula, A sub 2 minus 1 plus 6. Now 2 minus 1 is equal to 1, so it's negative 3 times A sub 1 plus 6. A sub 1 we found earlier here was negative 1, so negative 3 times negative 1 plus 6. And so final answer, that's negative 3 times negative 1 is 3. 3 plus 6 is 9. So that's the second term. We need the 4 terms. So the third term, negative 3 times A sub 3 minus 1 plus 6. So that's negative 3 times the second term plus 6, so negative 3 times 9 plus 6, and that's going to equal negative 21. We'll go ahead and start boxing these numbers so we can remember what they are. The fourth term is negative 3 times the third term. Just sort of substituting that in really quickly since we kind of have a feeling for what's going on. It's like negative 3 times the previous term plus 6. So in this case, negative 3 times negative 21 plus 6 gives us 69. So the first four terms listed in the sequence, negative 1, then 9, negative 21, and then 69. Notice this is just a sequence, not necessarily an arithmetic sequence. In fact, it's not an arithmetic sequence, but it is defined using a recursive rule. Some more of the problems you might see are these, which prompts us to determine whether or not each one of these sequences are arithmetic or not, and if they are arithmetic, to find the common difference. So we'll just look at the difference between each one of these terms. So from negative 14 to negative 10, that's a plus 4. Then another plus 4. Then another plus 4. That's arithmetic. Common difference of 4. Looking down here at this term, 20 to 15 is a minus 5. 15 to 10 is a minus 5. 10 to 5, negative 5. Arithmetic, common difference, negative 5. And our third situation, negative 2 to negative 10, is a difference of negative 8. From negative 10 to negative 50, that's negative 40. And at this point, I can say, hey, those are not common. This is not arithmetic. I'm done. Let's move on to the next problem. So this one, if you look at, you might think, oh my gosh, find the 76th term of the following arithmetic sequence. I'm going to have to carry this on for another 76 times or whatever, and the answer is not if you know the formula. And we know that formula. That formula is that the nth term is equal to the first term plus the d times n minus 1. So in this case, 3 is our first term. And looking through here, definitely looks like there's a plus 6 between each one of those terms, so common difference. So here we go. Let's just plug in the formula. The 76th term is equal to the first term plus 6, common difference, times 76 minus 1. So that turns out to be 453. We didn't even need to do plus 6 plus 6 plus 6. Yeah, it's pretty much straightforward there. In fact, this has a close resemblance to that more generic A sub n and m formula. I'll let you think about those similarities there. All right, last problem. Here we go. I'm going to scratch out that bottom part down there. So here we go. This says, for the given arithmetic sequence, the 75th term, a sub 75, is equal to 544. And the 11th term, a11, is equal to 96. Find the value of the 42nd term, a42, somewhere in between those. So I don't know about you, but I kind of like having some sort of like number line type thing going on here. So we've got our sequence and it's traveling along here, and the 11th term is 96, and we'll just keep traveling along here. And so the 75th term is 544, and they want us to find the value of the 42nd term. So that's that guy right there, which we don't know what he equals. Okay, so now it's time for that awesome formula where, you know, we counted the space between them and then divided that by the number of hops, and we found the space per hop, and yeah, okay, yeah, great. So that formula was the nth term, that's supposed to be an n, looks like an r, but it's an n, is equal to the mth term plus n minus m times d. And I always like to have like the nth term as the final position, so that's sort of like my rightmost position, is equal to m as the leftmost position. Now, it doesn't necessarily have to be that way. You could switch n and m, but then everything else has to align with that. So, but I'm going to follow that convention that the n is the rightmost term. So, in this case, that's going to be a sub 75 is equal to a sub 11 plus the 75 corresponds to that number right there. So 75 minus 11 times d. I'm doing all this here right now to be able to actually find that common difference d. So 544 equals 96 plus 64 times d. Subtract 96 from both sides, divide both sides by 64, and you get d equals 7. Oh, that was nice. Nice round number there. So so you can imagine I've got plus 7, plus 7, plus 7, plus 7, plus 7, plus 7, and I'm trying to get to 42. Okay, Well, that's not very difficult. I just can apply this same formula again to find out what the 42nd term is. Only this time my nth term is going to be 42 and my mth term is, well, it's still going to be that a sub 11, but I'm not traveling all the way here to 75. I'm just going right here. So I'll write that formula again one more time. So a sub n equals am plus n minus m times d. So in this case I'm looking for the 42nd term, so a42 equals a11 plus 42 minus 11 times that common difference of 7, which is what we needed to find out a minute ago. The 11th term was 96, so we have 96 plus 31 times 7, which gives us a total of 313. All right, so in this lesson we looked at arithmetic sequences, exactly what they were, and then we looked at explicit formulas, recursive formulas. We even looked at this formula right here, which shows how to find the nth term given an mth term and a common difference, and then how to apply all those formulas and build them and find the common difference. It's been a great lesson. Thanks for watching.